Hello students, welcome to this video. In this exercise, we're gonna find the time that is needed for a light ray to travel to a piece of window glass. And we are also going to find, what is the thickness of water that light could travel, in the same amount of time. So the exercise in question says this. How long does it take light to travel to a 3 millimeters thick piece of window glass? And then they say through what thickness of water could light travel in the same amount of time. So let us then solve the first part of the exercise. What do we know in this case? Of course, we know the speed of light, which is 3.0 times 10 to the 8 meters per second. We know the thickness, right, of the piece of window glass. So this thickness, I will call this TH, and this TH is equal to 3 millimeters. Of course, in this case, we know that 3 millimeters is the same that 3 times 10 to the negative 3 meters. This conversion will be important later. And we know the index of refraction of glass, and this index of refraction of glass that you can find in any book is going to be 1.5. This is for glass. So then we know that the index of refraction is the quotient between the speed of light in vacuum and the speed of light in a given medium. So if we want to find what is the speed of light in glass, we need to divide the speed of light C vacuum by the index of refraction. So in this case, we're going to get 3 times 10 to the 8 meters per second divided by the index of refraction of glass, which is 1.5. So when we do the calculation, we will get that the speed of light in glass will be 2 times 10 to the 8 meters per second. So with this speed of light in glass, we can now, using a very basic equation, right, that we know from kinematics, we can find now the time that takes to the light rate just to cross through this 3 millimeters piece of window glass. So we know that the distance is equal to b, so the speed times the time, and this is a basic equation of kinematic for uniform motion. If this distance x is the thickness of the glass, and we divide the thickness of the glass by the speed of light in glass, we're going to find the time that is needed, for the light ray to cross through this piece of window glass. So we can say that T is equal to x over b, where this x is going to be the thickness. So I just called before the thickness just th, so it will be th divided by b. So it's going to be 3 times 10 to the negative 3 meters divided by 2 times 10 to the 8 meters per second. Now we divide, and of course the unit of time will be seconds, and we're going to get that this is 1.50 times 10 to the negative 11 seconds. So the time that takes to the light to travel to a 3 millimeters thick piece of window glass is just 1.5 times 10 to the negative 11 seconds. Now, the second part of the problem is asking about, through what thickness of water could light travel in the same amount of time. So what have changed now from part A to part B of the problem? Well, we know the index of refraction of water. And the index of refraction of water would be 1.33. Again, you can find this index of refraction in any book. So what are we going to do now? We know that the index of refraction is equal to the speed of light divided the speed of light in vacuum divided by the speed of light in a given medium, right? So if we want to find the speed of light in water, we just divide the speed of light in vacuum by the index of refraction of the water. So we're going to divide 3 times 10 to the 8 meters per second by the index of refraction, which is 1.33, and we're going to get now that the speed of the light, in water is 2.3 times 10 to the 8 meters per second. So you can see the light travel faster, through water than through glass. So now we can find the thickness of water that the light will travel in the same amount of time that we had for the glass. So we use exactly the same equation of kinematics, x, which is a distance, right? And then we're going to call this the thickness. Remember that in this case, I will just call the thickness prime because it's going to be the thickness of water, and this will be equals to b times t. So will be equal to the speed of light in water times the time that we found in the previous step. So now we have that this thickness is going to be the value we found of 2.3 times 10 to the 8 meters per second times the time, that is 1.50 times 10 to a negative 11 seconds. Of course, the seconds are going to be cancelled out, and we're going to get the thickness of water that the light will travel in the same amount of time that the 3 millimeters of glass would be 3.45 millimeters, right? So this is after performing all the calculations. So it will be 3.45 times 10 to a negative 3 meters which is 3 millimeters, 3.45 millimeters. And here we got our answer. So I hope this exercise was interesting for you. Please subscribe to my channel and support the work we're doing solving this exercise. Thank you so much for your attention.